Hey you guys, thanks for joining me in another video with my properties of logarithmetics. So in this introduction series, we've talked about where it came from, some extinctions or how it is an extension of exponents. And today we're going to talk about some ways to just simplify their expressions. So let's get there. Again, we're going to be simplifying some expressions. Alright, let's recall. So, logarithmics is exponents. It legit is. If you look at this graph down here, 10 to the power of x in red, and then we have log base 10x. They look so similar. That's because they are inverses of one another. They are. Where you have xy coordinate for one, you have the yx for another. Like, it's legit the same, just the inverse. All right, let's get back into it. So what are we talking about today? We're talking about simplifying expressions. So here are some rules to know, and we'll apply these later. All right, y'all, look at this first one. We have log base a 1 that equals 0. So this is useful because we know that a to the power of 0 is 1. So let's see. If I said that I have 4 to the power of 0, well, that is 1, right? Yeah. So if I have log base 4, 1, what do I raise 4 to get 1? You could raise it to the power of 0. So you'd have that equal to 0. Yeah. All right, let's look at this next one here. I'll switch my colors up. So this one says log base a equals 1. Okay, so a being any, let's say any integer right now. Okay, so since a to the power of 1 is a, we can say that this log expression is true. So if I have 14 to the power of 1, well, 14, yeah, that's 14. So that means that log 14, base 14, 14, what do we raise 14 to get 14? We raise it to 1. Yeah. All right, this next one here, we have log base a raised to x. So x being any, let's say any number, it equals x. So if I have, let's say I have, trying to be a little abstract with my numbers. Let's say I have 71 raised to the power of 2. Well, that is the same thing as 71 to the power of 2, right? That's it. It equals it. It equals itself. Duh. Yeah. All right. So if I have log 17, base 17, and then I have 17 2. All right, so what can I raise 17 to get 17 to the power of 2? Well, of course, we're going to raise it to 2. So we're going to put that 2 there. So, yeah, x would be 2. All right, this last one here. So this last one, we have a raised to the power of log a x. So this, I want to call it an inverse property. So because these a's cancel out each other, I don't want to use a on this. Let's say I have 2 log base 2 of x, and this always equals x. Because look, these 2's, they cancel out one another, which just leaves us with x. Yeah, always true there. So I'm going to go back to that blue. So if I have 14 log 14 to the power of 7, now these 14's are going to cancel out, leaving us with just 7. Yeah. And that would be the answer. Okay, this video is getting lengthy, but it's good discussion. So let's look at these. Log base 6 to the power of 1. So what power do we raise 6 to get 1? We raise it to the power of 0. So this equals 0. I'm going to say since 6 to the power of 0 equals 1. All right, let's look at this next one here. Log base 15 equals, well, what do we raise 15 to the power of to get 15? We raise it to the power of 1. So that's since 15 to the power of 1 equals 15. Alrighty, next one here. It says log base 4 to the power of 9. What does that equal? Okay, so what can I raise 4 to get 4 to the power of 9? You have to raise it to the power of 9. Since 4 to the power of 9 is the exact same thing as 4 to the power of 9. I like that little pattern I got with the colors. So look here, we have 7 raised to the power of log base 7 to the power of 3. Now remember this rule, we can cross these two 7s out, which means this is going to equal 3. Yep, that inverse property there. Exactly. All right, y'all. Well, you have made it to the end of my videos. Thank you for practicing and learning with me. Feel free to leave comments or suggestions. See you next time.